on centuries of translation, synthesis, and original discovery that had taken the Greek inheritance and transformed it into something far more powerful before passing it on. Step outside tonight and look up. Find Betelgeuse. Find Rigel. Find Aldebaran. They are still there, carrying their Arabic names across 1,400 years, named by men who sat in the darkness 1,000 years ago and looked up at the same sky, and decided that understanding it was a holy act. The algebra your children study was written by a man in 9th century Baghdad who believed that the pursuit of knowledge was an obligation placed on him by God. The surgical tools in every hospital on Earth trace their lineage to a physician in 10th century Cordoba who spent his life trying to reduce human suffering. The scientific method itself, the idea that truth is established through observation and experiment, was articulated by a man sitting in a darkened room in 11th century Cairo, watching light move through a hole in a wall. We live in a world built by the Islamic Golden Age. It is in the stars above us. It is in the mathematics we cannot live without. It is in the hospitals that keep us alive. It is in the very way we think about what it means to know something. The Golden Age is gone, but it never stopped teaching. And it is still teaching now. It built on the foundation and then pretended the foundation was not there. How did one civilization produce this much knowledge this fast? And how did the world manage to forget almost entirely where its most important discoveries actually came from? That is what this is about. To understand how extraordinary the Islamic Golden Age was, you first need to understand what the world looked like before it began. Rome had fallen. The western half of the empire had collapsed in the 5th century under wave after wave of migration and invasion, and with it had gone the infrastructure of ancient learning. The great library of Alexandria was gone. The philosophical schools of Athens had been closed by the Emperor Justinian in 529 AD, their scholars scattered. Greek scientific and philosophical texts, the accumulated intellectual achievement of Aristotle, Euclid, Archimedes, Galen, Ptolemy, existed in fragments, mistranslated copies, and disappearing manuscripts scattered across the ruins of a civilization that no longer had the institutional structure to preserve them. Western Europe in 700 AD was a place of genuine intellectual poverty. Monasteries preserved fragments of ancient knowledge and deserve credit for that preservation, but they were not producing new knowledge. They were not building on what they had saved. The intellectual culture of early medieval Europe was, by any honest measure, contracting. Meanwhile, the Persian Empire had just collapsed under the Arab conquest. India and China were intellectually active but isolated, brilliant civilizations, producing extraordinary work that the rest of the world had almost no mechanism to access. The world in 750 AD was fractured. Great knowledge existed in pockets, in different languages, in different traditions, with no way for those traditions to speak to each other. And then the Abbasid Caliphate built the mechanism, and everything changed. In 762 AD, the Abbasid Caliph Al-Mansur founded a new capital on the banks of the Tigris River in what is now Iraq. He called it Madinat al-Salam, the city of peace. The world would come to know it as Baghdad, and within a generation, it had become the largest, wealthiest, most intellectually alive city on earth. But the moment that truly changed history came in 830 AD, when Al-Mansur's grandson, the Caliph Al-Mamun, established an institution that has no real parallel in all of human history. He called it Beit al-Hikmah, the House of Wisdom. It was not simply a library. It was not simply a university. It was something the world had never seen before, and has never quite seen since. A translation bureau, a research institute, a debating chamber, and a think tank, all combined into a single institution, funded without limit by the most powerful ruler on earth, with a single overriding mission: gather everything. Al-Mamun sent emissaries across the known world with chests of gold and a mandate to find every manuscript of scientific and philosophical value that existed in any language, anywhere on earth, and bring it to Baghdad. Greek texts that had survived in Byzantine monasteries, Indian mathematical treatises written in Sanskrit, Persian astronomical tables compiled over centuries by Zoroastrian scholars, Syriac medical texts preserving the clinical observations of physicians whose names had been forgotten. Everything that human civilization had ever written down about how the world worked, gathered, translated into Arabic, cataloged, studied, debated, and systematically built upon. The chief translator of the House of Wisdom was a Christian scholar named Hunayn ibn Ishaq. He translated the entire surviving works of Galen and Hippocrates into Arabic, with a precision and scholarly rigor that would not be matched in European translation work for another 3 centuries. He did not simply convert words from one language to another. He compared multiple manuscript versions, identified corruptions and errors, reconstructed missing passages from context, and produced translations that were more reliable than the originals he was working from. Working alongside him was a man whose name most people in the modern world have never heard, whose work they use every single day of their lives. His name was Muhammad ibn Musa al-Khwarizmi. In the early 9th century, Al-Khwarizmi wrote 2 books that changed the intellectual history of the world. The first introduced the Indian positional numeral system, including the concept of zero, to the Islamic world and eventually to Europe, where it replaced the Roman numeral system that had made complex calculation almost impossible. The second book was titled Al-Kitab al-Mukhtasar fi Hisab al-Jabr wal-Muqabala, the compendious book on calculation by completion and balancing. European scholars later translated it into Latin. The word al-Jabr in the title became, in their translation, algebra, and Al-Khwarizmi's name, Latinized, became algorithm. Every time your phone runs a search, every time a computer processes a calculation, every time a child solves for X, Al-Khwarizmi. But he was not alone. He was not even the most remarkable figure working in Baghdad in that century. The House of Wisdom, in its golden decades, was so dense with genius that it reads less like a historical institution and more like a thought experiment about what becomes possible when you remove every barrier between the greatest minds on earth and the resources they need to work. There was Al-Kindi, the first systematic philosopher of the Islamic world, who wrote over 250 works on mathematics, physics, music, medicine, and cryptography, and who produced the first known description of frequency analysis, a technique for breaking coded messages that remained the most powerful tool in cryptography for the next 700 years. There was the Banu Musa brothers, 3 sons of a Baghdad astronomer who produced works on geometry, mechanics, and celestial motion, and who built mechanical devices of such ingenuity that European scholars encountering their descriptions centuries later assumed they must be fictional. The House of Wisdom was not an isolated phenomenon. It was the center of a network, and that network stretched from Spain to Central Asia, from the shores of the Atlantic to the borders of India, connected by a single language and a single intellectual tradition that made it possible for a discovery made in Cordoba to be read, debated, and built upon in Samarkand within years. This network produced things that deserve to be named. In Cairo in the 11th century, a scientist named Ibn al-Haytham, known in Europe as Al-Hazen, sat in a darkened room and watched a beam of light pass through a small hole in the wall and project an inverted image of the street outside onto the opposite surface. He had built a camera obscura, but what he did with that observation went far beyond the device itself. He proved, through systematic experiment and mathematical analysis, that vision works because light enters the eye, not, as the Greeks had believed for 1,000 years, because the eye emits some kind of visual ray that reaches out and touches objects. This sounds obvious now. It was revolutionary then. And the method he used to prove it, careful observation, controlled experiment, mathematical description of results, was the scientific method, articulated clearly and completely, 4 centuries before Francis Bacon, 5 centuries before Descartes. His book of optics directly influenced Roger Bacon. It directly influenced Leonardo da Vinci. The principles it established led, through a chain of influence that can be traced step by step, to the telescope, the microscope, the camera, and the entire optical technology of the modern world. In Cordoba, al-Zahrawi, a physician whose full name was Abu al-Qasim Khalaf ibn al-Abbas al-Zahrawi, spent decades producing a 30-volume medical encyclopedia that remained the standard surgical reference text in European universities for 500 years. He described over 200 surgical instruments, many of which he designed himself. The surgical needle, the scalpel, forceps, the technique of using catgut for internal sutures, which dissolves naturally in the body. A surgeon in a modern operating theater picking up a scalpel is holding, in direct conceptual lineage, a tool that Al-Zahrawi designed in 10th century Cordoba. In Bukhara, a man named Ibn Sina, Avicenna to European scholars, wrote the Canon of Medicine at the age of 21. A systematic, comprehensive account of the entire state of medical knowledge, organized with a logical precision that made it instantly recognizable as the definitive reference work in its field. It was translated into Latin in the 12th century. It was used as the primary medical textbook in European universities, in Paris, in Bologna, in Oxford, until the 17th century. 600 years of European medical education resting on a book written by a 21-year-old in Central Asia. In the 11th century, Al-Biruni calculated the circumference of the Earth using a method of his own devising, measuring the angle of depression of the horizon from a mountaintop, and arrived at a figure within 1% of the value determined by modern satellite measurement. He also proposed, based on his geological observations, that the Indian subcontinent had once been covered by sea, a hypothesis not confirmed until the development of plate tectonic theory in the 20th century. In the 12th century, Muhammad al-Idrisi produced a map of the world for the Norman king Roger II of Sicily, so accurate that it was used by navigators and geographers for the next 300 years. He drew it with south at the top, a convention that confused European scholars for centuries, and that modern cartographers have only recently begun to question. Look up at the sky on a clear night. Find Orion. The bright red star at his shoulder is Betelgeuse, from the Arabic Ibt al-Jawza, the armpit of the central one. The bright blue star at his foot is Rigel, from the Arabic Rigel al-Jawza, the foot of the central one. The bright star that marks the eye of Taurus the bull is Aldebaran, from the Arabic al-Dabaran, the follower. The bright star in the constellation Lyra is Vega, from the Arabic al-Waqi, the falling one. Of the 210 brightest stars visible from Earth, over half have Arabic names. Not because Arab astronomers discovered them, humanity has known the bright stars since before history, but because it was Arab astronomers who cataloged them, measured their positions with instruments of extraordinary precision, calculated their movements, and gave them the names that every culture in the world still uses today. Now here is the question that this extraordinary record demands. Why here? Why this civilization? Why this period? The answer is not a single thing. It is three things that had never existed simultaneously before and have never quite existed simultaneously since. The first was language. Arabic, by the 9th century, connected scholars from Spain to Central Asia to India in a single intellectual network. A mathematician in Baghdad could read the work of a physician in Cordoba and an astronomer in Samarkand without translation, without delay, without the distortion that translation always introduces. This had never happened before on this scale. Greek had connected the Mediterranean world, but not Central Asia or India. Latin connected Western Europe, but not the Islamic world or the East. Arabic connected almost everything. The second was theology. The Islamic intellectual tradition contained, at its core, a mandate for inquiry. The pursuit of knowledge was not merely permitted, it was framed as a religious obligation. The hadith attributed to the Prophet, "Seek knowledge even unto China," created a cultural atmosphere in which scientific investigation was not suspicious or potentially heretical, but actively virtuous. A Muslim scholar studying the stars or the human body was not challenging his faith, he was fulfilling it. The third was patronage. The Abbasid caliphs competed with each other to attract the greatest scholars to their courts. Al-Mamun did not merely build the House of Wisdom, he personally participated in its debates, corresponded with scholars across the world, and funded research with a generosity that had no precedent. Scholars were paid salaries, experiments were funded, books were commissioned. The state had decided that knowledge was power, and it invested in knowledge accordingly. These three things together, a common language, a theological mandate for inquiry, and generous state patronage, created an environment in which the greatest minds of three continents could find each other, fund each other, challenge each other, and build on each other's work across generations. It was the most productive intellectual environment in human history, and it ended. Not all at once, not with a single catastrophic event, but through a series of blows that arrived over 2 centuries and never allowed full recovery. The first and most devastating blow came on February 13, 1258. Hulagu Khan, grandson of Genghis Khan, arrived outside Baghdad with a Mongol army. The Abbasid Caliph Al-Mustazim refused to surrender. The city was taken by force. What followed was one of the most catastrophic acts of deliberate cultural destruction in human history. The House of Wisdom was destroyed. Its books, hundreds of thousands of manuscripts representing 4 centuries of accumulated human knowledge, the translations and the original works, and the commentaries and the astronomical tables and the medical encyclopedias were thrown into the Tigris River. Contemporary accounts say the river ran black with ink for days. The Abbasid Caliphate, the political and financial structure that had created and sustained the Golden Age for 5 centuries, was extinguished in that single week. The caliph was executed. The city that had been the intellectual capital of the world was reduced to rubble. Baghdad lost in 1 week what it had taken 5 centuries to build. The second blow was subtler and in some ways more lasting. Within the Islamic intellectual tradition itself, a theological shift had been developing for decades. A growing argument that certain forms of philosophical inquiry, particularly the Aristotelian logic that had been so central to the Golden Age's method, were in tension with Islamic faith. The most influential expression of this position came from the scholar Al-Ghazali, whose work argued that the philosophers had gone too far, that reason had limits, and that revelation must be the final arbiter of truth. Al-Ghazali was not a simple anti-intellectual. He was a sophisticated thinker engaging with real theological tensions. But his influence, amplified over generations, gradually narrowed the space in which radical, boundary-pushing inquiry could flourish. The third blow was the centuries of crusades and conflict that shifted the Islamic world's resources, attention, and institutional energy from intellectual production to military defense. A civilization under constant external pressure has less capacity for the kind of patient, generationally sustained research that the Golden Age required. The light did not go out all at once. It dimmed over 2 centuries, until what had been a blazing fire was reduced to embers. But the knowledge did not disappear. It had already traveled. The translations that began in Baghdad moved west through Persia and Al-Andalus into Europe. The manuscripts that Islamic scholars had gathered, translated, studied, and built upon arrived in European universities through Toledo, through Sicily, through the scholars who fled Baghdad carrying what they could save. Ibn Sina's canon reached Paris. Al-Khwarizmi's algebra reached Oxford. Ibn al-Haytham's optics reached London. Al-Zahrawi's surgery reached every medical school in Christendom. The European Renaissance, that great explosion of art, science, and humanism that we credit as the birth of the modern world, was not built on ancient Greek foundations retrieved directly from Athens. It was built on Islamic foundations, on centuries of translation, synthesis, and original discovery that had taken the Greek inheritance and transformed it into something far more powerful before passing it on. Step outside tonight and look up. Find Betelgeuse. Find Rigel. Find Aldebaran. They are still there, carrying their Arabic names across 1,400 years, named by men who sat in the darkness 1,000 years ago and looked up at the same sky, and decided that understanding it was a holy act. The algebra your children study was written by a man in 9th century Baghdad who believed that the pursuit of knowledge was an obligation placed on him by God. The surgical tools in every hospital on earth trace their lineage to a physician in 10th century Cordoba who spent his life trying to reduce human suffering. The scientific method itself, the idea that truth is established through observation and experiment, was articulated by a man sitting in a darkened room in 11th century Cairo, watching light move through a hole in a wall. We live in a world built by the Islamic Golden Age. It is in the stars above us. It is in the mathematics we cannot live without. It is in the hospitals that keep us alive. It is in the very way we think about what it means to know something. The Golden Age is gone, but it never stopped teaching, and it is still teaching now.